Hey everybody, welcome to Shaper Sessions. My name's Jake, and we have a new face joining us today, my friend Russ. Welcome, Russ.
Hey everybody, I'm Russ.
Russ is going to start doing some sessions with me, and tell us a little bit about yourself, Russ.
Yeah, cool. So I'm a technical content producer here at Shaper, and what that means is I work on marketing projects like sessions and anything that you see on Hub that comes out of Shaper, I've usually had a hand in. I'm a lifelong woodworker and also a metalworker, machinist, welder, CNC enthusiast, and so I'm really stoked to be here and share some of that knowledge with you all.
Right on. I'm stoked to have you. And today we're doing tambour doors, sliding tambour doors, and how to apply them to a small bedside table. We learned a lot of things along this journey, and we're excited to share with you all the little lessons that we learned. We learned a lot from looking at the people that are out in our community. We know Michael Alm has made a video using Origin to do tambour sliding doors. Philip Morley is also a big inspiration for this one. And then Jonas Winkler, one of our premium project creators, actually, while we were getting ready for this session, uploaded a tambour sliding cabinet on Shaper Hub. Funny enough, using black MDF, which is what we'll be doing again as well here today. Total coincidence, but I love it. So you can find that on Shaper Hub already. You can find this project on Shaper Hub already. And
yeah, we got tambour in the air over here at
Tambour is
Shaper
really
HQ.
popular right now. All right, so what is tambour? Let's at least start with the sketch that kind of started it all. Goose, if you could bring that up. Wanted to make kind of a small cabinet that combined double-blind dados, box joints, and this sliding tambour door all into one small package. So that was kind of the rough sketch idea, and we took it from there. We started by figuring out what our tambour profile looked like. I'll bring this down here. Each slat is about 3/4 of an inch wide. Things that I learned from watching people like Michael and Philip Morley are, that I didn't suspect, is that this little rabbet here is really, really handy. I thought you would just make this the slide part as big as your slat, but in fact adding that rabbet does two things. One, your slide doesn't need to be as big, and two, once everything's put together, that little bit of a lip actually does a really great job at hiding the track. That's the word I'm looking for. The track quite well, and it makes it a little bit smaller. In addition, we threw chamfer on both edges to really highlight each individual piece because I thought it looked really cool. All right, so this is going to be our tester, and we're going to start off by just using OnTool CAD to figure out what our radiuses are going to be, because that can't slide around a 90-degree turn. So we got to think about what's our minimum and maximum radius that's going to look good and also slide well.
Mm-hmm. We're also, at this point, we're going to dial in the thickness of that track, right? The width of the track.
And that's just all using OnTool CAD and offsets. So I got my 1/4 inch bit in there. I am just using some scrap MDF, and we'll make a couple paths and a couple cuts to see which one we like best. I always end up just throwing things around here. All right. I'm on my workstation. I'm using shelf and double-sided tape. Let's go ahead and bring a new scan in.
Yeah, and this is really a perfect project for Origin right here, because we're quickly prototyping and iterating on what we want our more detailed final project to be. And we can do that super flexibly on the tool and test as we go.
All right, we're in design mode. We're just going to go ahead and create a couple of rounded rectangles. Let's do something like 10 by 10. That first corner radius, I'm going to say 2. And I'll grab that upper left anchor point. Again, I only really care about this area because that's the radius that we're testing for. I'm just creating a couple of squares, rounded squares, so that it gives us that radius, and that's what we're going to be testing our tambour slide in.
Yeah, this is going to become our track. So we're going to make inside cuts on these rectangles and use offsets to tune the width and tune the corner radius with corner rounding on Tool CAD in Origin.
Yeah, so this next one's a 3-inch radius. And let's do one more for kicks and giggles at 4 inches.
And we could have made a grid here, but since this is totally comparative, we're just testing the different tracks and how they work with our tambour sample. It doesn't really matter that they're aligned to each other or anything else.
Not at all. All right. Do a 1/4 inch cut. And I know that I'm going to have to make it a little bit bigger because that rabbit is not exactly a 1/4 inch, and plus we need to make it bigger to go around the radius. But I'll start with 1/4 inch on all of them, and then we'll start adding that offset.
Yeah, cool. So Jake's plunging here, and what's important about this cut is just that we get the edges nice and smooth, that we get the thickness correct. So it's going to take some offset dialing in to get the width offset for the tambour to fit in that slot. And then also he's just making sure that he goes from one edge all the way around so that we can insert the whole length of the tambour sample in the slot. Just taking a couple passes here. Looks like he's on the second rectangle now. And just going with that straight 1/4 inch bit cut at a 1/4 inch depth or so, it looks like. And we'll do all 3 of these and just see how they fit. And then we'll play with the offsets. Like we said, we're probably going to need an offset on this, almost certainly. But just cutting the 3, and then we'll add the offset when we get to it.
Running into it. But from top view, you could probably see already what those radiuses are going to look like. There we go. So that's our 4 inch, our 3 inch, and our 2 inch.
Yeah, sweet. Well, how's it fit, Jake?
Probably won't.
Nope, not at all.
Not quite. So let's add.
That's what we expected.
We can do. I'm going to extend these down all the way through.
Yeah, so we're extending these down all the way through just so that, again, just so that we can get that sliding action all the way around the corner. Really important to, as we go prototyping this, just getting this quick prototype as close to the real feel of the final product as we can.
All right, now I can throw in an offset, let's say, like, probably pretty big, 0.07. That makes this path 0.32 inches. I'm going to pretend like I haven't done this before and say that I think that's going to be perfect.
It might be perfect. We'll see how it goes. So, yeah, probably could have measured this also, but the beauty of Origin is that with the offsets, you can just sneak right up on it as well. So we're adding a couple hundredths of an inch as we go, and we're just gonna do a quick cut and check. And I don't remember exactly what the final dimension on that tambour sample is, but we'll see if it fits. I think it might be a little bit bigger than this. Sneak peek. But yeah, at least intermediate steps and sneaking up on it with offsets. It's easier to take more wood away later than it is to add it back after you've cut it away. So just a couple hundredths at a time, offset, and that'll give us a nice clean cut edge too, because we're not removing as much material at once. Vacuum that out so that the tambour slides nice and smoothly.
Yeah.
Get that dust out.
It's nice to be using like an ultralight MDF like this because it just cuts like butter. Very little resistance on the tool and with a fresh cutter. All right. So
yeah.
that fits in the straightaways, but what I'm really concerned about is my radiuses. So this is the biggest radius, it's the 4-inch radius, and that feels like great. But it's pretty big, so let's see what our 2-inch looks like. That starts to get a little snug in the 2-inch. I can't actually make it around that turn. And maybe the Goldilocks here, 3. Perfect.
Yeah, I love that.
For the sake of it, why don't we open up this last one just a little bit more, so we can try to see what a 2-inch looks like, 2-inch radius looks like. Let's just do this at 0.1 offset.
Yep, and like we said, sneaking up as you go. But the cool thing about adding that rabbit on the bottom of the tambour slats is that even if you overshoot this a little bit, the track is going to be covered by the full width of the slat. So we have about 0.3 inches at the bottom of the slat, but the full thickness of that is 0.4 inches or so. So even if we overshot this track by up to 0.4 inches, it would be covered by that rabbit that you made.
So I can already tell you that is starting to feel like a little too much slop in the straightaways just to allow me to get around that corner. But at this point, it's an aesthetic decision. I think 3-inch gives us a nice clean curve. It feels not too snug all the way around, slides smoothly.
Yeah, I think the 2-inch is a bit aggressive,
yeah,
and the 4-inch is a bit soft.
Yeah.
3-inch is a good middle ground.
All right.
Plus, we already did the rest of the project
yeah,
that way.
It's like
we're just showing you how the pudding's made here. Yeah, we're going with 3 inches.
Yes, but this is like a really, and I would even make note. So I did a 0.07. I added 0.07 to a 0.25 inch cut because my cutter is 0.25 inches, so that's 0.32. So now I know that my path needs to be 0.32 inches. So when I move over to my design software, in this case I was using Illustrator, I knew that that was my size, 0.32. So I'll just
exactly
make note of that.
And the point of doing this is so that you don't have to design the whole thing and then do all of these offsets on your final project.
Absolutely. And there's always the reality of when you get to your final piece, you're still gonna want to sneak up on it because it's now the real world application.
That's
you want to make sure you're cutting into your expensive material. You want to get it right the first time.
Yeah.
This gives us an idea of where we're at, and I may have to take. And when we move to the final project, we might have to start taking like a couple of negative thousandths of an inch off, just to open it up a little bit more.
And that could be the difference between our tambour sampler here and your final tambour door that you end up making also.
Exactly. So with that information, we can go ahead and move forward and make our actual tambour panel, which was
this is incredible.
Which was definitely a learning experience. So that same profile with the rabbit cut out across every single one of them, but I don't know, if you ask me, I think that chamfer on each piece was like,
yeah, it makes it pop.
I think it's fun.
And there's a million different ways to do this.
Yes.
Which we can get into all the different ways to glue it, but also all the different ways that you can lay out your material. What we did, or what Jake did, he did this door himself. But what Jake did here is line the grain up vertically, and I think that works really well with the chamfer here because it makes that vertical grain pop. If you look at Jonas Winkler's project on Shaper Hub, he has face grain on his, and the whole sheet is basically a continuous grain.
So cool.
And he did not add any chamfers on his to keep the look of that continuous grain. And it's just two different ways that you can attack the same project.
I can't even imagine how he did that. He must have had a really small kerf saw blade.
Yeah.
Or something.
Something.
Because it is a very continuous grain.
It's really nice. Check it out.
Yeah. So, yes, there we go. That is the original drawing. That's kind of what we're playing with. And, yeah. Let's talk about how we glued it together, because that was a trick in its own. I didn't know what kind of glue you would use. Turns out there are many different ways you could do this.
Yeah, totally. So this was pretty critical, right?
Yeah.
This here in gluing up all those slats. Pretty tricky to get 30 slats aligned perfectly freehand, right, Jake?
Exactly. So it gives you a couple of straight edges to reference against. I just used pin nails to hold it all together, and then that last piece I just really pushed in to hold all those things together, so that when I started rolling my glue on, I had zero, if any at all, squeeze out in between each of these slats, because I wanted to be really careful not to glue these guys together accidentally. Part of that has to do with the viscosity of your glue, and how much you put on. I probably went a little light on the glue, but it's holding up. So
yeah, so let's just like walk through this, right, and pop this in here and show everyone how it works.
Yeah. So it's a really snug fit. I don't even know if I'll be able to get this last one in there.
Yeah, I wouldn't even worry about it.
But what
That's
this allows,
the idea, though.
Holds it all together. Ah, yes.
There we go. You see that?
This offset was all done just with blue painter's tape, because I don't want to put any glue here, and it gave me a really clean line to basically cut my fabric flush against. So it's glued all the way up to the edge like that.
Yeah, super crisp. And what kind of fabric is this, Jake?
I just went to the local art store and got some painter's canvas.
Yeah, and
sure you could use. You just don't want it to be flexible. So canvas has very, very little flex, but you don't need to get too fancy with it. Wouldn't use like a jersey cotton or something, but canvas seems like the way to go.
Yep, and you used a standard wood glue.
I used
a
standard yellow wood glue, rolled it on. I put it both on the fabric and the slats. Probably could have saturated the canvas a little bit more. I've seen people use hide glue and saturate both parts. Contact cement, which of course you put on both parts, let dry to a tacky feeling, and then you have one shot to get it on there, which that sounded kind of stressful, so decided not to do that.
Yeah, especially with flappy canvas. We did that with the linoleum tabletop, but that stuff's a lot easier to work with than canvas, I imagine.
A little bit more rigid.
Yeah.
And then Jonas Winkler, in his project, he uses the same webbing that he uses in his stock chair project, and just staples. So stretches that webbing across, puts a staple in the back of each of the slats, and I really like that as a quick glueless method.
One other glueless method that we ran across also, which I thought was pretty cool. We didn't end up trying it out for this project, but Rockler makes a set of router bits for your router table that actually make interlocking tambour door slats. So one side will have a positive and the other side will have a negative, and you slide one slat, the negative, onto the positive of the other. We would have to do that 30 times, and then they lock together. Seems pretty time consuming, but it's a good mechanical interlock and no glue required.
And once you get your router table set up, I'm sure you just hang out there and
just
get
zip
it all
them
done.
all out.
Yeah.
Yeah.
That's a fun alternative too.
And one thing we glossed over, I think, is the one thing that you ran into which is that it's pretty difficult to apply finish to this after it's
Yes.
glued up, isn't
Yes.
it, Jake?
Yeah. In fact,
Fortunately, I don't think that mistake was made, but caught it in the nick of time.
no, I actually didn't put finish on this one. This is going to be our tester one. But the reality is, depending on what kind of finish you're using, it is really difficult to put finish on this thing once it's already glued to its fabric. You can imagine,
Right, like how do you get inside all of this?
Yeah, I actually, even to let the glue dry, I draped it over the side of a trash can just in case there was a little bit of glue in between each slat. I didn't want them to glue to itself. So finishing would be the same thing. You'd have to drape it over some sort of arch. Anyways, better way to go about it, finish each piece individually. Using painter's tape on the back panel, on the back of each piece rather, just to make sure that you don't get any finish there, so that the fabric will stick to it and the glue will stick to it, and just do all your finishing work ahead of time because it'll be a lot easier. Yeah.
And that's a theme that we're going to revisit
Yeah.
on this project a couple of times.
Hindsight's 2020.
Yeah, this Tambour stuff's kind of tricky, but that's why we're sharing everything that we learned with y'all. Yeah, I think that's everything that we learned for the Tambour itself.
As far as the Tambour itself, let's hop into the many lessons of the case itself.
Yeah, cool.
So made it a little bit more difficult on ourselves by deciding to do a box joint and tambour kind of combination here, but we figured it out, and I think we did it in an elegant way.
Yeah, this is a really cool build.
So originally in my mind, I was like, why couldn't the tambour be fully captive? i.e., as you assemble everything, that you put the tambour in, you put the top, and it's all sandwiched in together. And then after I put it together, dry fit it, I realized, finishing that once it's glued together would be an absolute nightmare. And so that's why you wouldn't do it that way.
Yep.
So that leaves us to a lesson that I should have learned when I saw Philip Morley's Instagram post. He has an entry and an exit point for his tambour slide. That does a couple things. One, it allows you to glue the case up and the tambour up separately and finish them separately. And two, if 30 years down the line, tambour needs to be serviced or remade or anything, you don't have to break the case open. You can just slide it out the back. So that makes a lot more sense. And so we thought, okay, we've already cut these pieces. Let's make an edit to it, which is really, thankfully, really, really easy with Origin and Workstation, because we can probe directly off the pre-cut piece that we've already done and make an edit to that, knowing that our file is gonna land exactly where we want it to. And then we ran into another issue.
Yeah, so let's show these off on the bench cam for starters. This is our pre-edited piece, and we'll show you edit A and edit B also. So originally, let me flip this around. Originally, our tambour track looked like this, and you can see the tambour door itself fits right in there, but was totally captive in the track. So we realized earlier that we need to include that entry and exit point. So the first thing that we tried was this rounded entry and exit point right here, having seen that on Philip Morley's Instagram. But what we didn't think about was that his tambour geometry must have been a little different than ours and allowed it to recurve back. Ours only curves this direction and doesn't curve back the other way because we only have a chamfer and not a full round on that. The sides are straight, so it doesn't curve back on itself. But what we had tried was this round exit here, and Jake, if you pop that in there, we can show why that doesn't work.
Can't make that bend.
Doesn't make that bend.
Doesn't bend that way whatsoever.
Yep.
So
then we went back for edit B, which was to trim the back of the case. Originally, the back of the case went all the way from the top to the bottom here, from left to right. But we just trimmed off this whole finger of the box joint on the case and extended this track straight out back. And since this is the rear of our bedside table, or the wall side, ideally this should be back against a wall, no one's ever going to see this. And that's another tambour tip, actually, also. that on our full-size door, the door actually goes from here to about here or so. Let's pop this door in so that we can show everybody what this looks like. So if we get this in the track, there we go. So this is the back. You can see this is open. And this is the front. So when you're looking at the front of your case, this backside, which is toward me, is back against the wall. And even though that tambour section is open, it's closed off by our shelf, and then it's also back against the wall. And then when we pull this tambour around as if we were opening the thing, that's where it ends up, because your tambour always needs somewhere to go.
Right.
So one way that you can do it is with a track style like this, where it's just kind of one-dimensional. It goes from a start to a finish point, and you have to leave some empty space for the tambour to move into. Another potentially more complex way to do it would be to wrap that tambour in upon itself within the case. But we already had this going this direction, and so we just extended that track so that if you need to repair your door or also for assembly, you can just slide that tambour right out.
Another thing too, for primarily people make enclosed tambour cases, so like the back would actually have a panel on it, so the tambour slips kind of behind a panel. So the back is never really open, but in this use case, it didn't really matter if it was open.
Yeah, but check out Jonas Winkler's Shaper Hub project for an
totally
example of a totally enclosed tambour console.
So we edited our first one.
Oh yeah, back to edit 2.
We got to make our second edit now that we figured out that that is in fact the way to do it.
So we're just going straight out the back here.
And it will still be, still be hidden because it's in the back corner.
And we saved one to do live.
Exactly, just to show. So that's our unfixed one. And I just need to extend that path out all the way. And I'm going to be putting a little double-sided tape here.
And this is, now that we've made this revision, this is already included in those SVG files that are uploaded to Shaper Hub now.
Yep.
But quick edit on our side. And the cool thing about Origin is with the easy probing, we'll just get right back to where we were on this part.
Boom.
Little double stick tape.
And I am working in this area. Because I'm using double-sided tape and I have a huge cantilever, I wouldn't try to work way out here just because I'm relying too much on that double-sided tape. So if I'm doing operations, I'm doing them up here as best I can. I'm going to zero out my shelf height. And I'm going to do that tricky style of grid where I'm going to use the back end of the bit. You know, typically I would grid front, side, but now I'm going to grid top, side. So that gives me a 0, 0 point of right up there. Start with that new scan.
Yep, just catch enough of that part right there that you can see what you're working on.
Now the one thing you have to make sure of when you do this style of grid is it assumes that you want to use the front of your bit, or I should say the face of your bit that's facing away from you. You can always manually change that with that button right there. Now it's showing me that it's using the face of the bit closest to me, and I'm just backing it up. Contact, and around to the edge. Bingo.
Beautiful.
Now I can come in and grab I believe that was the bottom. I have a custom anchor point set up there, so I got to rotate that 180. And just in case you haven't yet, I'm running Inverness right now, and if you haven't upgraded to Inverness, what are you doing? Make sure your tool's on Wi-Fi so you can upgrade to our latest software release, Inverness. You get all kinds of awesome updates, including pinch zoom everywhere, custom anchor points, enhanced positioning features. Yeah, I feel like
custom anchor points are awesome.
We've been ringing this bell for a while now, but just in case you haven't done it yet, go do it.
Rotate, flip. Flip's a good one.
Yep. All right, so I'm just popping this down at 0, 0. But that custom anchor point makes it really easy because I have this little overhang here. And otherwise, if I didn't have a custom anchor point, it would assume that that is the edge of my file, when in fact, this is the edge of my file that I care about. Pop into cut, take that offset away, or actually put just a smaller offset. And I'm just going to extend this path out. I want to make sure that I Z-touch.
Cool. So you can see how super simple and quick it is to make edits to your project as you go on Origin. With that grid, we ended up exactly where we left off on this part, especially with the custom anchor, being able to go right back onto that corner. Looks like we're trying this with a small offset to start, and similar to before, we're going to sneak up on it. So there's one cut, and let's see how it goes. Yeah, it looks like Jake's adding a little offset here, or maybe some more depth. Quick inside cut.
All right, easy peasy. I just did a slight negative 5 thou offset just because I think I added that to the entire track. So like we were saying earlier, even once you get to the final product, you're going to need to make tiny adjustments potentially, and being able to do that with offsets is a really wonderful thing.
Mm-hmm. Let me say that was a very nice sounding cut, Jake. Like a nice even hum.
Yeah.
Yeah,
good.
I like that.
This black MDF is really interesting stuff. I don't know what they use to dye it, but and it cuts like butter, and it may not look particularly interesting now, but when you put finish on it, whoa, it is beautiful. Like all the richness of the black, and even like this subtle flake kind of comes out in a really, really nice way. Yeah, big fan of colored MDF recently.
Yeah, makes a good stable case, I'm sure.
Yeah. It does suck up a lot of finish though, so you have to, it's a big sponge for finish.
Sweet. Well,
it's assembly time.
What do you say we put it together?
Yeah, it's exciting now that we don't have to try to assemble the case and the tambour at the same time, because that was a little tricky.
That was tricky.
But it was tricky. So let's go ahead and do the case first and slide in. Oh, while we're at it, we decided to do on-tool box joints. That's something that in the Shaper Hub project we just mention in passing really, but that's on tool. There's no file for that. The pieces are 14 inches wide. Set up your box joints. I decided to do sure, I can show where it is at least. For those that aren't familiar, when you're in design mode and create, right there you got your box joints, and it allows you to make custom box joints to whatever width and thickness your material is. So I did odd number of pins. I believe I did like 15 pins. You could do more, you could do less. 14 inches is pretty wide though, so if you're doing a lot of pins, just remember that you're going to be there doing it for a while. Another thing to think about too when you're doing box joints that are wider than your cutter, you need to change it to a pocket first. You need to clear out that material as a pocket So then you can come back in to an inside cut and clean that up to look really nice.
And sneak up on your offsets also.
Always
with
sneak
this,
up
just
off your
like
offset.
everything.
Yep.
Cut one first probably. You would cut the back of this first, wouldn't you, Jake? And then do the sides, or would you do the top and bottom before you do the back?
I cut both the top and bottom first because these are both my A parts.
Ah, okay.
And I did that with a 7 thou glue gap. And then when I moved to my B part, which was the back, before I finished the cut it to 0-inch offset, and before I pulled it out of Workstation, I just double checked that everything felt good. And if I needed to at that point open it up a little bit more, that would be the time to do it, but it worked out pretty nicely. It was snug, but not too snug.
And pretty cool that you can do 2 A parts with probably the same setup on Workstation,
That's
right?
it.
With some of the locating features.
Yep.
So you just pull out those 2 screwed locating pins on one side or the other and use those as a reference for both A parts and then probably both B sides too.
Precisely.
Right?
And as long as I kept my registration edge similar, which in this case was the back of my cabinet, the back edge of my cabinet, I just want to make sure that I'm always aligning that same edge to those registration pins, just in case there is any like slight offset or whatever it may be, or your material is slightly different. At least you're aligning one whole face to be the same.
Yeah,
cool.
I think that covers box joints. Yeah, let's put this together.
Let's hammer it together.
Cool. This is the back. This goes in a little bit later, right? This is our center piece. Here's the shelf. So those go together. We've got our hammer over here. And let's see, you designed this. So
I know,
you're
so I'm going to
the
sit back
expert.
and watch you do
Oh
it.
man, see if I can put the puzzle together. Okay, well, let's see. I know this goes in here. So one note designing for Origin is that you do end up with these corner radii on all of your dados, right? And so, yeah, we can bench cam that. We've got these corner radii right here from the 1/4-inch cutter that I assumed you cut this with, Jake.
Correct.
And so one quick step that we would take on any project with a blind dado like that is to either chisel out those corners, which is a pretty cool skill to learn, and then you can work with square stock, or just take your stock and use a round over bit on the corners, and then that'll fit just perfectly without doing that kind of a little cheesy at this point dog bone, CNC dog bone.
Yeah.
You don't want that on your fine furniture nightstand.
For something like this, I'm not going to put exposed dog bones. You could still
Maybe
do
on the
hidden,
cleat wall.
Yeah, you can do hidden dog bones, but even that, I find this little like roundover trick to be so satisfying because it just fits so nicely.
Yeah.
Just.
So this is going together pretty well so far.
Yep.
That shelf just pops right in there. Let's see. So I know that this is going to go.
I would do that side loosely, and then I would put the back on because you have.
Okay, because we've got to put this together also. So we've got the back. We want to make sure that our track here, which is open for our tambour entry and exit, is open also on the back. So we ended up slicing this off when we made that edit round 2. So we've got our box joint there. I gotta get straight. There we go. And pop the shelf in the back.
So is the fun part when you have a lot of different things coming
got
together.
3 different things lined up right now. There we go. That feels pretty good. Okay. I'm gonna take this and just hammer this home a little bit.
I love it. Nice and squeaky.
There we go. Okay, well, let's see what this does. Got our fingers there. Get that nice and square. We've got the center section, which is not even close to being fully assembled on that side yet. So we got to come back over here.
Tolerances are tight.
They're snug. Looking, that's all. That all ought to be square. Oh, there we go.
There's the movement.
That feels good.
There's something to be there's
You
something to be
assemble
said.
one thing and then the other thing comes apart.
There's something to be said about different tolerances on different materials. Certain hardwood, most hardwoods, you're going to have to open things up larger because when you're trying to assemble something, it's not going to give on you. But something like MDF, which is a little softer, you might keep your tolerances a little tighter so that when you are assembling, things are going to compress ever so slightly, and usually just enough to kind of bring it together really nicely and hold well with friction.
There we go.
There we go.
That looks pretty good. That looks pretty square to me. Give us a couple more quick thwaps.
Yeah, that looks good.
That looks good. Sweet. So we've got our front here, and then side, back, and this piece ties it all together with the box joints here. All right, dude, you want to do the honors?
Let's slide it in. This is the exciting part.
Oh, yeah. Nice. So that's our back. And this is our front.
That is awesome.
That's pretty slick. And one thing that we noticed, again, after this was all put together and we thought it was wrapped, but it would be nice to add a little handle
Probably
right here on the door. But it works. It works as it is.
Yep. We also, originally, as you could probably saw in the drawing, we were going to do kind of an box jointed L leg that came down. I think I decided to go against that. We're going to do 4 legs that come out of it. TBD on that one. Probably tapered or kind of angled and tapered legs using Morris and tendons that go into the bottom of this is going to be the route that I'm going to take. But now it's great because we can glue it up, finish it, or glue it up, sand all of our box joints nice and flush, finish it, and then assemble it, and
yeah,
figure out from there. We also figured it could be a wall-mounted cabinet very, very easily.
Yeah, pretty robust.
Yeah.
This thing's nice and solid. Good, what is this, 5/8 or 3/4?
3/4
MDF.
black MDF. What's nice too is, and we put this in the instructions, I went 1/4 of an inch deep down here, but I went a little deeper up here on the track. Now I wanted to make sure that there was nothing that was going to bind on this, so I wanted to be able to slide totally freely. But what keeps it all nice and square is the blind dado depths are exactly 0.25. So this is a structural element in there, also gives you an additional shelf, and allows the tambour to slide a little more freely and give it some space.
One thing I just noticed,
What?
we're adding edits to edits here, but you pulled the door back and it made this little tail right here, which is you don't want it to do that when it's at your bedside. Although this is ideally up against the wall, you don't want it to do that. So
Yes.
I just thought of this. We could put a little dowel here and here.
Perfect.
To stop the tambour from coming out of the track.
Right.
And then if you need to repair it ever, you just pull that dowel out and then tambour comes out of the slot like you intend it to. So
We're learning things.
we're learning things as we go. Yeah, exactly. Yeah, let's talk a little bit more about finishing. There's one more tambour tip that we didn't cover, which is to wax your track. So we're going to finish this whole thing, and this feels really, really good already. But if you want your tambour door to just coast, wax your track.
Wax your track using a paste wax or something like that. It'll make it feel a lot better. It feels good now, but it has some resistance, right? You can feel that friction. Another point to that would be soften the edges of the rabbet. So the bottom edges of all of these are still pretty crisp because they're fresh off of the dado stack on the table saw. So just softening those edges with some sandpaper might decrease any friction as it goes around, especially around the radius.
Yeah.
And yeah.
All good stuff.
A quick design tip, like how we actually made this thing.
Oh, yeah.
It was all based off a rounded rectangle again. So in Illustrator, and much like on Origin screen, made a square, in this case 14 by 14. Two of those edges are radiused with a 3-inch radius, so we figured that out in our test. And just using the feature offset path, we stepped it in 1/2 of an inch, offset path again, use that dimension of 0.32, so that's how wide we wanted our track to be, and made that a solid object, and boom.
Yeah.
So the whole thing was really based off of the outside dimension, just kind of worked its way in.
And not everyone has Illustrator,
Nope.
and that could be pretty complex for someone who's just getting into digital design. So if you need a hand with any design questions or problems, get at us at Shaper Assist. We provide design services to help you make the files that you need to run Origin and make cool projects like this. This one's available on Shaper Hub, so go download that. But if you've got any different tambour geometry that you want to explore, something a little more complex, we'll help you out.
Yeah. Whether you don't know how to make it or you just don't have time,
yeah,
let us help you out.
Yeah, busy professionals.
Yeah.
Also, if you're busy cutting stuff in the shop, you might not want to spend the time to sit down at the computer. Our team here is really quick at that.
Good, affordable rates.
Yeah. Shameless plug.
All right. I think that's all we have for you.
I'm set. Yeah.
All right.
That's good by me.
Thank you all for joining us. It's been a pleasure. We will see you next Thursday for another session